In question 22, it says the velocity time graph for an object moving along a straight path is shown in figure P 2.22. Part A, find the average accelerations of this object during the time intervals 0 to 5 seconds, 5 to 15 seconds, and 0 to 20 seconds. Part B, find the instantaneous accelerations at 2 seconds, at 10 seconds, and at 18 seconds. The concept in this problem would be average and instantaneous acceleration. Now, just as we had a concept for average velocity, and we could find average velocity in two ways, we could find average velocity by using the formula change in position over change in time. Reality is, this is really just the slope of a position time graph. Similarly, to find average acceleration, A bar, it's the change in velocity over time, which would be velocity final minus velocity initial over time final minus time initial. And you could very well fill out the portions of this using information from the chart. But I also like to think that we can do this an easier way too. And we could simply make it the slope of the velocity graph to get the acceleration. Let's see how that works. Part A, we want to know the average acceleration from 0 to 5 seconds. Now, 0 to 5 seconds has no slope. So, since the slope is equal to 0, the average acceleration is equal to 0 from 0 to 5 seconds. From 5 to 15 seconds, it is this upward slope right here. Now that upward slope could be measured a variety of ways. We can go up 8 over 5. We can go up 16 over 10. Either way, the slope, and thus the average acceleration, would equal about 1.6 meters per second squared. Notice the new unit now. Meters per second squared would be meters per second per second. Lastly, the third one, we want to find from 0 to 20 seconds. Now from 0 to 20 seconds, you kind of have to imagine an imaginary line going all the way up like this. Now, we have to take the slope of that line. Well, that would be either up 8 over 10 or up 16 over 20, just as a couple possible examples. Giving us a slope of about 0.8 meters per second squared. To find the instantaneous velocities, it's the same thing. It's the slope of a velocity time graph. However, it's the slope at a particular time. So the velocity at 2 seconds equals the slope at 2 seconds. Now, 2 seconds would be about right here. So if I go down to the graph right here, I can see that's part of a flat line. A flat line has 0 slope. Therefore, 0 acceleration. The second time mentioned is at 10 seconds. Well, 10 seconds is right here, right in the middle of that sloped line right there. And again, the instantaneous acceleration, equals the slope, which is a slope of about 1.6 meters per second squared. Same as the average acceleration we found between 5 and 10 seconds. And lastly, the instantaneous acceleration at 18 seconds, which also equals the slope, again equals 0. Because if you look on the graph, at 18 seconds, which would correspond to about right here, that's a flat line. Flat line having 0 slope.